Okay, this will be example number 2 in solving linear equations by the graphical method. And we're going to use a little bit more of a complex example this time for our example number 2. So first of all, my example that I have is I've got equation number 1. I've set that as being 2y plus 4x is equal to 5. And equation number 2 I've set down as y plus 2x is equal to 1. And what we want to do here is we want to find the intersection point, if possible, for these 2 points. So what we're going to do here is solve each of these equations for one of the variables. And I'm going to choose y again. So 2y equals, subtract 4x from both sides, 5 minus 4x, and then divide by 2. So y would then equal 5 minus 4x all over 2. Okay. And over here, we can just solve by subtracting 2x from both sides. Y is equal to 1 minus 2x. Okay, so we're going to set up our table of values now for both of these lines. Now, you'll notice that in this example, it's going to be very difficult to obtain perfect numbers for the graphical method, and that's one of the limitations of trying to solve equations graphically. And sometimes it's very difficult to be exact. And I just wanted to mention that while we were doing this one, as you will see. So I'm going to put in here y is equal to 5 minus 4x over 2. And then we're going to try and come up with 3 points here. I'm going to leave a little more space this time because I might have to do a little more work. This one here will be simpler. Y is equal to 1 minus 2x. And then the y there. So this will be our table for equation number 2. And we'll try to come up with 3 points there as well. Okay, so what I'm going to do here is I'm going to choose some points that will work out reasonably well. Now, if you look here, if I choose like a 1 or a 2 or a 3, it's going to give me some really uneven numbers. Now, if I choose multiples of something or so, like 5 or so, it might work out, but I'm going to just choose here 0 to start with. So this would be y is equal to 5 minus 4 times 0 all over 2. Well, that's 5 over 2. Well, 5 divided by 2 is what our y ends up being. So what does that mean? That's 2.5. So 2.5, or 5 over 2 if you like. So not the best number, but an okay number. So now I'm going to choose a negative 1 here. So I have a negative number. So that would be 5 minus 4 times negative 1 over 2. So that would be 5 plus 4, because those two negatives, over 2. So that would be 9 over 2. 9 over 2, which equals, if you work that out to a mixed fraction, that's 4.5. Okay, so we're getting halves in this case. Okay, and if I want to choose a positive number here now, let's choose 2. So I get y is equal to 5 minus 4 times 2 over 2. So this would be 5 minus 8 over 2. Well, that would be negative 3 over 2. So negative 3 over 2. So that's negative 1.5. 1 1/2. So not the best points, but not too bad. At least I can probably graph the halves. Let's do the next point here for line number 2. So I'm going to choose 0 here. Again, y is equal to 1 minus 2 times 0, which is 0. So y is equal to 1. Then I'll choose, let's go with negative 2. y is equal to 1 minus 2 times negative 2, 1 plus 4, which is 5. And let's choose positive 2 this time. Y is equal to 1 minus 2 times 2. So that'd be 1 minus 4. That'd be negative, in our case, negative 3. So we have 3 points for each line. We have 0, 1, negative 2, 5, and 2, negative 3 for this line. And over here we have 0 and 2.5, and 1 and 9/2, kind of scrimping it in there, and then 2 and negative 1 and 1/2. Okay, so I'm going to draw my Cartesian plane on the bottom here again. And let me just check my video to make sure that you'll be able to see where it is. Okay, that should be all right. I'm going to use so this will be my y, and this will be my x. Okay, so there's my Cartesian plane. Okay, I'm just going to slide this up just a smidgen here. Okay, so we're looking at graphing the first line. So I'm going to take my pen here and go 0 and 2.5, 0 and 2.5, 1, 2.5. So it'll be there. Negative 1 and 4.5. Negative 1 and 1, 2, 3, 4.5. There's 4.5 would be about there. And then finally, 2 and negative 1 and 1/2. 2 and negative 1 and 1/2 would be all the way down here. So using 3 points, I should be able to see if they line up here. And there they are. So draw my line in there, make the arrows on the ends so that we can see it, and label that as line 1. Okay, I'm going to take the red marker again and do line 2. So 0, 1. Okay, and then I have negative 2 and 5. Negative 2 and 5. And then I have 2 and negative 3. We can see here an interesting thing, that these two lines don't intersect. They are actually parallel lines. So I'm going to label this here. 2. So if you have parallel lines like this, like these two lines turned out to be, there is no solution set for that system of linear equations, meaning they never cross. So there is no solution. We have parallel lines. Lines, which will mean that there's no solution that satisfies those equations. So we don't need to check it there. One way we could look at it is, do they both have the same slope? Looks like it, and they have different places where they cross the y and x axis. So that would mean that they are definitely no solution and they're parallel. When we get into the next section, we'll be looking to classify linear systems under this category as well as the other categories. So that's example number 2.